Purple one. Okay, people, so database design. As I explained last time, the whole purpose of a database is to store large amount of data, but to store it in an organized manner so that we can extract the data. Doctors, firms, schools, companies like to store either their assets or their employees or anything like that in a database so that we can extract and use the data efficiently. All good? All right. So you'll see first thing that you need to know. Okay, they talk to you about what is a database, so you can read that. Then they want to know, they tell you here what is data and information. Okay, then those of you that can remember grade 10, we also did this. Data is raw, unprocessed facts, while information is the processed data. So example would be, if we take everybody's ages of the class, that is data. Just having lots of ages, so that's something. But now if you want, to make that information is if we work out what is the average age, what is the highest, what's the lowest. Now it's something we can use, because now just saying the ages of the class is 10, 20, 30 doesn't mean a lot. But now if we can say, okay, but the grade 11 class average age is 23 and the oldest person is 95. Now suddenly it tells you something about what's happening. Alright, so data, raw unprocessed facts. Information is processed data. Basically like the statistics about the data, sort of. Alright, something very important, especially for grade 12 as well. Characteristics of quality data. Alright, there's 6 of them, you need to just learn them. It's just, you learn it, I'm going to ask it, you just give it back, you get the marks. Alright, so first thing there is it must be accurate. So you'll see they give you some examples here, like the weather prediction 27.2 is a nice warm day, but 2.72 is a problem because it's much colder. So making small mistakes like that could make a big difference, even if it's off by a little bit. So it needs to be accurate. Whatever we store in a database needs to be correct to the decimal and so forth. Correctness itself. So this is also where that, you remember we also did the word GIGO, garbage in, garbage out. So if you type in wrong information into a database, whatever you use the database for will then also give you the wrong stuff. It needs to be current. Okay, so it needs to be current. So it won't help if you've got a database. Okay, like for the school, our database will have all the learners that's in the school, plus maybe the previous 5 years grade 12s. It's the data we should keep. But if in our database, we've still got learners from 1980, their information is still stored in our database. Do you agree? It will just make it all skewed, because all of if you think for yourself, what we will have of you, we'll have your parents' details, telephone numbers, physical address and that. But now think of people that was here 30 years ago. Their telephone numbers, parents most probably passed away already, moved away, different addresses, and so forth. So it needs to be current data. Actually, the people that you've got now, the assets you've got now, whatever you store in the database should be current information. It needs to be complete. We can't have a database for the school, but let's say only have grade 8, 9, 11 and 12 learners. And the grade 10 learners we just don't add. Or we just add certain people. If it's not complete, you agree the database would sort of be useless. Because now if I ask, give me all the grade 10 learners, but anyone's name is not entered, now I won't get all the grade 10 learners. So it needs to be complete. It needs to be relevant. So for the school, it won't help us creating a table to store the amount of cars driving past, or to store the weather for every day. You agree? It's just no use. There's no relevancy to the school having a database with what's happening in the weather or COVID cases of China. It's just no relevance for us. And it needs to be consistent. Means data in one part of the database should not contradict or differ from the other one. You should not have, I can't think of an example now, but you shouldn't have information that you store in the one. If you do that in one table, we work out the average age for grade 11s and it's 15. But in another part, when you do the average age for grade 11s from another table or something else, then it's 23. So whatever we store, just it needs to be the same things that we're storing everywhere. Alright, so it's these 6 things: accurate, correctness, current, complete, relevant, and consistent. You learn them, they'll ask it, we'll never ask 6. I think at most we'll ask for 3 of them. So know at least 3 and be able to explain all of them or understand all of them, because the other question could be, we can give you the definition and then ask you to give us one word. Then you must know, oh, it's consistent for this. Or reverse, we can ask you to explain relevancy for us, and then you must understand what is relevancy. So understand all of them, but at least be able to name 3 of them in tests. Okay, validating your data. This is different things. We'll do this more. So for now, for this year, it's not important. Next year, it's very important. We will definitely look at it. It's very important, especially for your PAT next year. But this is things that we can remember. We get validation, verification. Remember that. Validation is something the computer can do. So that's something we can do in our database. So we can validate by checking the format, to making sure that an email address has got an @ sign, to make sure that the date is year, then slash, then a month, then slash, then the day, and so forth. We can data type check to make sure when you ask for the age that it's only integers. When you ask for a name that it's only strings. We can do a range check. When we ask for ages for learners for the school, that it's between 13 and 23, because there's not supposed to be anything. So that's a range check. Check digit. So that's the part where we can, like with gender, check that it's a M or F. And check that it, for ID numbers, check that it's only digits that start in. Alright, so all these things, these are different things we can do to validate our data. Database design tips, nice reading. All this stuff is how to collect data, also nice reading. Valuable information, it's good reading. You can read all this stuff, it's very interesting. Manipulating, it's also very interesting. Calculated fields, very interesting. We'll do more of this next year when we do our SQLs. We'll start creating our own calculated fields. Nice activity for you to do when you're bored. Creating a simple database. This is what you're going to do in the very near future, like just later on. Important words, these blue ones. Alright, so let me quickly show you. I opened a database here. I found one database on my computer, which is for golf. So with golf, so this database, so there's a database for golf, and there's 3 tables. Remember, the table holds related data. So we've got a table for the hole. So those of you that know in golf, there's normally 18 holes. So there's the 18 holes, and then there's a par score. How many hits it should take you to get into the hole. So this is the information that you need for each hole. Then we've got a player table, where there's a player ID, a first name, surname, manufacturer, handicap, join date, club reference. So all the information about players that's going to play golf. So all the information about those people. And then there's a table for the score. So which player, when he was playing which hole, how many hits did he take? So you can see all the players are there with each hole they played and with the amount of hits they took. So this is something, so this is tables inside a database. So a database would be for something, so this is for golf. And then tables are related data. So there's table for the holes, there's table for the players, there's a table for the scores. There might be then a table for the employees and so forth. So you'll have the different tables storing the information for the different groups of objects in that company. Then you'll see our first word here is a field. Remember, those of you that can remember, a field is a column. So the table player has got 1, 2, 3, 4, 5, 6, 7 fields. It's got a field for the player ID, a field for first name, for surname, manufacturer, handicap, join date, club reference. So there's all these ones are fields. The table whole has got 2 fields for the whole number and for the pass score. Each row, what do we call a row again? Yes, a record. So each row is a record. So that is one record. The whole number 5 has got a pass score of 4. So it's the information of like one object is a record. If we look at this table, like this one, val and time that's one record. So it's the information about that one person. Then we've got our primary key. Who can remember the primary key? Yes. So it's the field that will uniquely identify each record in the table. So if we look at this one, which field will we use here? The player ID. Because you agree, if I say look at player ID 8, it will only be one person. So that player ID will uniquely identify only one record. And you'll get all the information of that. So player ID would be a primary key field. Alright, don't worry about that one yet, but a composite key, composite primary key, is like in this table. If we look at this third table, the table score, which field can be a primary key here? Can player ID be? If I say player ID 1, will you only get one record? No, there's 18 records for player ID 1. If I say whole number 1, will I only get one record? No, there's whole number 1 and there's already on what I can see 2 records with the same. If I say score of 5, will I only get one? No. So do you agree not one of these fields can be a primary key? Alright, so this is where the composite key comes in. They say if we combine 2 fields, the combination of them becomes primary key. So will we find in this table player 1's whole number 1 score more than once? And you won't. Player 1's whole number 1 has only got one score. And that's what makes it. So the combination of the two makes it a primary key, and that's called a composite key. So composite key is a primary key, but it's made up out of more than one field. Primary key is just one field, but if we can't get one field, then we can use a composite primary key, where it just takes more than one field to make a primary key. Okay. Foreign key, don't worry about that one. Data types is just like when we do surname, data type will be short text. You can, when we talk about databases, you don't need to stick with the Microsoft Access words. If you say string, it's fine. If you say text, it's fine. If you say short text, it's fine. Like with numbers, in Access, they just talk about number. But if you say integer or double, that's also fine. So you don't need to worry too much about choosing the specific one for Access. As long as you basically look between text, number, currency is also one, date and time, and then maybe Boolean, or yes or no. You can say well, yes or no as well. Is your one you'll choose. Records, we explained. Each row. The table we explained is the whole thing. A relationship is how 2 tables are linked with each other. Okay, don't worry too much about that for now as well.